Let me check your homeworks. Where's your homework again? Okay, yeah, no, I just put it like, yeah, and then I brought I simplified it. Maybe by against the extra. All right, so questions from homeworks. Any question from homework? 23, sure.
For 44?
You're trying to find like the answer. Yeah, no, but I looked at that.
Oh, what is that?
I think that's 23. 23, I have 23. I have a graph. There is a tangent line. There was a tangent line over there. That with that tangent line, there is a slope. How do you figure out a slope? It will intersect at y-intercept at 0, 2, go down to 4, 0. So that slope has to be negative 1/2 in order to have that. So you just have to read the graph and extracting the slope. Does that make sense? And then, yes, McKenna.
Sorry, I pre-hinted under and he was wondering what it smelled like.
Oh. Bathroom smells bad?
No, I pre-hinted it on my hands. The soap in the bathroom doesn't work.
Oh.
Oh, there's no more soap.
That, all right. So that's the question 23. So you build a equation tangent line and just plug in 2.04 or 1.98, whatever they want you to plug in. Because here it's going to give you a dx. Do you see that this dx is 0.04? If you subtract with that value, that's going to give you a dx. And then you're going to get 0.98. I don't know what's the other one they want you to do, but yeah, this is one of them. Questions? Who says? Thank you, Fiona. I always enjoy people ask me questions because I think a lot of time that you just nod and pretend and just move on. And the homework, you gotta make sure that you did it on your own. Don't just copy someone else because you copy someone else, you don't really understand that you just did your homework. That's it. That's not the purpose of homework. So 25, Fiona is asking g of 3 is equal to 8. This is a coordinate. This means 3, 8. Does that make sense? So you can build in the equation tangent line. Now, how do you find the slope? The problem with that graph is a g prime of x. So g prime of x is negative half, and you can plug in negative half here, and then you're done. Then just plug in 3.1. You want to approximate 3.1, plug in 3.1. The 3.1 minus 3 is going to give you dx, which is 0.1 here. Move it over 7.95 on one of them. I didn't do the other one, but you can do the other one. You can get the value for the other one. Huh? Yeah. Question 27 is right here. A equal to x squared, y equal to x squared, dy equal to 2x dx. Well, why is x squared? Because a tile, the area of a tile is x squared. X times x. It's a square tile. And then you just 2 times 10, and then it's going to be plus minus 5 or 8. Now, here's the thing. In the OAP exam, they ask you question differently. They also ask you something called relative error or percent error. Percent error basically just take the propagate error divided by the total area. Or it could be total volume, could be total area. But you can divide this by 100 and you got a decimal place, and that's going to give you a percentage. That's called a percent error. On chemistry, they deal with percent error a lot. Like, what's your error analysis? That's a big part of chemistry. Not everything is going to be perfect. You're going to come to an experiment, it's going to come up with a perfect result. Most likely, your result is going to be imperfect. I am a chemistry major. I would tell you that I was trying to make acetaminophen, which is the things that's etanol, and I come up with a 0.3% yield, which is bad because you're supposed to come out like at least like 30% yield, but I come out like 0.3% yield. That's because I'm doing something wrong. So I have to write down error analysis. Says, okay, where do I think I go wrong? Why is my errors low? That's all real life. So percentage error is very, very important. Questions? No? Yes? Maybe? Connor?
So you're a chemistry major. Did you like that job?
No, I hate chemistry. I did it for pre-med, and I was like, I did it for pre-med, but later on I was like, no, I cannot be a doctor. You're going to die. Adios. See you in heaven.
Oh yeah, he died.
Nobody will
What happened?
Nobody would like have you as their like
Primary doctor? Okay, so this one, how do I approximate 99.4? The way I teach you yesterday is this way. And honestly, this way kind of doesn't make sense for some of you guys. I understand. I probably do it this way though. Equation tangent line is y minus 10 equal to m times x minus 100. Why? If the x is 100, y value is going to be 10. So that is your initial condition. We're going to talk about the 2 word again, initial condition later. So this is the initial condition. Now, what is the 1 over 20? That's your dy dx. That's your slope. Now, once you plug in 99.4 in here, guess what? That's your error, which is your dx. And then you can see where the 10 come from. The 10 just moving from one side to the other side. So it's 10 plus 1 over 20 slope times the dx. And that's a reason why Caden was doing something, and yesterday and Vincent was just trying to show you a different way. Basically, this is just y minus y1 equal to m times x minus x1. 1/20.
Yeah, where did you get?
I take a derivative and I plug it in.
You plug in 100 for x.
Yep. Because when based on the x, our value is very next to x equal to 100. Because 99.7, so we base on 100. Huh?
Like the verse. What about?
All right. Can I move on or no? Baden, do you? Shh. Okay. What we're gonna do is we're gonna go to integration. So let's start with the notes. Oh no. I don't count them. All right. I think my proctor, my thing forgot again. She always forgot to come in my room. Okay. Shh. You guys spend a lot of talking. Make sure your phone away. I don't want if you take away your phone, but I don't really care. So what we're gonna do is we're gonna go into integrations. So we're gonna have a chapter 4 test probably on a block period, but I don't know yet. But actual things can change. But right now we're gonna start by looking at certain things. We're gonna start by integrations. What is the idea of integrations? So that's skill with templates. Apply. Okay, integrations. Now, imagine that you have dy dx is equal to 3x squared. Imagine that you have that. And now instead of saying stuff, I'm going to say, hey, can you tell me about what is y? Okay, so I want you to think about, don't shout it. I want you to think about it. Is it possible to finding y, and is it possible to come out a formula that can be determined these things? So those are things that you should always think about. I say don't shout it. Jesus. If you shout it, other people stop thinking, stop being an ass. All right, so it turns out that you can move the dx to the other side, and this process is called a separation of variable, and looks like what you did for yesterday's homework, which is called differential. Now, once you do that, you can do something called integrations. And this is the integration notations. Integration notation is also known as antiderivative. And I also think about this one since there's no boundary. Since there is no boundary, there's another name, it's called indefinite integral. Indefinite integral. So there was name integrations, antiderivative, or there's no boundary. We're going to talk about boundary later. There's no boundary. This one is going to be this. So what happened integration of dy? Integration of dy, just like yesterday. Think about before you take the differential, that's going to be y, right? Because after you take a differential, that's how you get dy, right? Is equal to, well, think about something, you take a derivative, it's going to be 3x squared. In this case, it's going to be x cubed, but it's not entirely correct. Why that s? Yes, Caden?
Because there could be a constant that could have been removed when taking the derivative.
So you must including this plus c. And if you don't have a plus c, unfortunately, I'm going to have to mark you wrong. So just make sure you have a plus c. This is a very, very important, because what Caden's saying is x cubed plus 2, x cubed plus 3. If you take a derivative of either one, I am going to get 3x squared. If I take a derivative of this is going to give you 3x squared. So, hey, the c is important because c could be represented for all other values. So we call this a general solution. The last time we saw general solution is in pre-calc, or in my class beginning of the year, when we have like pi over 6 plus 2m pi. And that's also known as general solution because not in a particular domain. You follow me so far? Okay. Here's this. Y prime is equal to 2. Can you find out why? Nope. Hold on. Nizar, what do you think? If y prime is equal to 2, what is y? 2x plus c. Good job. So this c still need to be there because it's important. Now, in other class I mentioned this, but there was different notation. If you have integrate of f of x dx, so if you integrate the f of x, notation wise, you can say that's a capital F of x plus c. You can say capital F of fx plus c. So they all means the same thing. It just go up one layer, and then the next notation is going to be capitalized. Or it can be like this, integration of f prime of x dx. What do you think is going to be? It's also f of x, right? Because one is derivative, one's without derivative. So they look the same, similar. But they represent the same exact meaning. Capital just a notation of you take an integral. And that's going to be a new function, and that function is we're going to call it capital F. Now also understand that, so this is something that you will see here, and that's it. If I have d to the dx of integration of, don't worry about this. What I meant is d to the dx of a constant. What's d to the dx of a constant? 0. What's the integration of 0 dx? C. Good job. Just integration of dx is going to give you a C. Yes, 0 dx.
When your derivative has like a denominator.
What do you mean?
Like if so, like you just did 2x, right? Yeah, 3x squared. But what happens if like it was 3? If your derivative was like 3x squared over 2x?
Then you can simplify that before you take integral. Okay, so let's say if I have d to the dx of kx, it's going to be what? If I take a derivative of kx, what's going to be what? Okay. What's the integration of k dx? What is it? K, what? No, kx. Let's see. Like integration of 2, that's going to be 2x, right? Because slope is 2, that means the function has to be 2x. It's just a slope. If I have d to the dx of k to the f of x, well, I can take the k out, right? And the d to the dx of f of x, well, we know that's going to be k f prime of x. Is that okay? I can take a constant out of a derivative, and I just can take a derivative of, for example, x squared. It's going to give you 2x and multiply the constant later. Same thing as k f of x. You can take a k out, and then that's going to be f of x dx, like this. You can take k outside the integral. If there's any constant, you can take it outside the integral. Which one first one? I'm just saying this k can be taken outside the integral. Same thing like k can be taken outside of derivative. Imagine you have 3x squared. If you take a derivative, that is going to be 3 d to the dx of x squared. And that's going to be 2x times 3. That's equal to 6x. Does that make sense? Okay, so far we all explained something that's very simple. But if I take I'm showing the derivative because they related. If I take a derivative f of x plus minus g of x, that's going to be f of x plus minus g of x. Does that make sense? If I take a derivative of two different functions, they can just break in two. If you do integration like this, that's equal to integration of f of x dx plus integration of g of x dx. But the rule does not apply with the multiplication, only in the addition. If multiplying cannot work that way. Some people want to see it that way, but it's not.
You didn't put for the f of x, g of x plus or minus. You didn't put a prime of g of x, but it's become.
Oh yeah, g
Okay,
prime.
wait, I wasn't sure if it was.
Okay, now we're gonna come down to the most important rule today. So this is the most important. It's called power rule. And you always did power rule before, except this one's a power rule for integral. So what if you have integration of x to the n dx? What do you think it's going to be? Let's ask somebody else beside those two. Let's ask Manisha. What do you think? If I integration to x to the n, what do you think the formula is going to be? Can you say it out loud?
Would you divide by n and subtract n by 1?
No, not really. So what will be the derivative of what is equal to x to the n? That's probably the way you think about it. Derivative of what function after you take a derivative is going to give you x to the n. Jenny, what you say?
That's an x to the power n plus 1.
Almost. No.
It must be the 1 over n.
Yeah, would it be?
Maybe.
Would it be
Fiona? Which one derivative is to give you x to n? Which function that take a derivative that's going to give you x to n? Bennett?
x to the power x plus fn plus 1 over n all over n.
Okay, Caden?
Yeah, that
X to the power of n plus 1 over n plus 1 plus constant.
Okay.
That's like literally what I said.
Imagine that if you take a derivative of that, right? The n plus 1 is going to comes down, cancel out the n plus 1, and then that n plus 1 is going to subtract 1, it's going to give you n. So just think about reverse thinking. This is the power rule of the integral. Is this okay? Now, with one condition, make sure that this is numerator. What I'm saying is does not apply to 1 over x to the n. Okay, it does not apply to 1 over x to the n. It's x to the n over 1, not 1 over x to the n. So don't get confused with that. Yes. You think about if I take a derivative of this, right?
Yeah.
This gonna put in the front, right? n plus 1, x to the n over n plus 1. And that will cancel out. Does that make sense?
Oh wait, what? Oh. That had to be
It cannot be 1 over x squared. It has to be x squared. It has to be on the numerator. Okay, so let's talk about also all the trig derivative. Because if you think about it, d to the dx of x to the n equal to nx to the n minus 1, right? So that's what lead to this. Because this one's an x to the n plus 1. You want an n plus 1 to cancel out, and you want an n plus 1 subtract 1 to be n. So that way, the only way to get there. Now, let's talk about all the trig derivative as well. If I take a derivative of sine of x equal to cosine of x, if I take a derivative, if I take an integration of cosine of x is equal to sine of x. That's the first one. Press C. If I take a derivative of cosine of x equal to negative sine of x, and if you integration of sine of x is what? Yep. Because you can take a derivative of negative cosine of x, it's going to give you sine of x. Now, if I take a derivative of tangent of x is equal to what? right? So that's gonna be integration of secant square of x dx is equal to what? Now realize that there was something missing. D to the dx of secant of x, tan of x, that's equal to secant of x. So integration of secant of x, tan of x is equal to secant of x plus c. So that's that. Two more. D to the dx of cotan of x. What is it? Anybody?
Tangent squared.
No. Cosecant square of x. So integration of cosecant square of x dx is equal to negative cotangent of x. The last one is d to the dx of cosecant of x.
Yeah. And equals that.
What?
Secant equals sex. Shouldn't it be sex equals sexy
Oh yeah, you're right.
Yeah.
My fault. Okay, so what's the next one? Derivative of cosecant of x is what? Negative cosecant of x, cotan of x. Does that make sense? Integration of cosecant of x, cotan of x, dx is equal to negative cosecant of x plus c. So we just talk about all the trig integral. We also talk about all the power rule. We also talk about basic simple rules. Now we're going to go into take it to integrations. Okay, so if you want to take a picture of this, you can if you want, but it's all the things I have. Yes.
Can integrals be negative or not?
What do you mean? Can it be negative?
Like, can you take integral of a negative number?
Yeah, of course. It's just a negative sign. Just think about it as a multiplication.
How come we didn't take it's just oh, we did that. Yeah, that's fine. Yes, we remember when it's negative, they were negative. You can negative on the end, just put on the end. Instead of putting on the front, you can
Okay, can I move on? Now, what we're going to do is take an integration of 3x squared. No, 3x. What's the integration of 3x?
Three over two, 3x squared plus constant.
So what you can do is you can take out a 3 outside. It makes easier to see. So that's 3x dx. Is that okay? This is a 1, right? So it'd be 3 to the x squared over 2 plus c. Why is 2 over 2? Because it's x to the 1 plus 1 over 1 plus 1, right? Does that make sense? So it'd be 3x squared over 2. If you take a derivative, the 2's can cancel. And that's it. Is this okay? Integration of square root of x dx. So remember that rule of algebra 1, a to the m times a to the n equal to a to the m plus n. A to the m over a to the n equal to a to the m minus n. Anything to the 0 power is equal to 1. Anything to the negative n is equal to 1 over a to the n, or 1 over a to the negative n equal to a n over 1. This is a very important rule. A to the m to the n is equal to a to the m times n. I'm just writing down all the exponent rule. You're supposed to know all this already. So I hear this is a 2, this is a 1, so that's going to be x to the 1 over 2 dx. So it'd be x to the 1 over 2 plus 1 over 1 over 2 plus 1. Now you know that this is x to the 3 over 2 over 3 over 2 plus c. If you divide it by 3 over 2, I cannot talk over you guys. If you divide it by 3 over 2, that's going to be 2 over 3, x to the 3 over 2 plus c. Does that make sense? Questions? Is this okay? Okay, we're going to get a little bit harder. So we'll be integration of 1 over cube root of x squared dx. Now remember, this is on a denominator, right? So you have to change it to what? You cannot take an integration here. You have to take an integration here. And that's going to be x to the 2 over 3 plus 1 over 2 over 3 plus 1. Oh, negative, sorry, negative. So that's going to be x to the 1/3 over 1/3. So it'll be 3x to the 1/3 plus c. Is that okay? What happens if you have this? Good. You have to expand and split. What time we get off here? All right. If you find this, I will always think about algebra before I do calculus. What the algebra thing I can do? Well, I cannot split yet. I can expand the top. So what I'm going to do is I'm going to expand the top. And that's going to give you an x plus 3 root x plus 3 root x plus 9. And that's going to be x plus 6 root x plus 9. That's equal to the x plus 6 root x plus 9 over root x. What can I do next? Yep. I already told you guys this is a very useful situation. And I can simplify this. That's going to be x to the 1/2 plus 6 plus 9x to the negative 1/2 dx. Now realize I did not take integral. I only did the algebra. So this is going to be x to the 3/2. This is 2/3. Plus 6x plus x to the 1/2, 18 plus c. And that's my result. How many of you guys are lost? Rotating, spinning wheel. I have one more thing to talk about though. How much time I have? 3 minutes? Okay. I suppose I have a like observation, but she never showed up on my observation date. I kind of knew that that's gonna happen.
You should be doing plus C all the time.
Okay, so now let's talk about why plus C is important. This is called initial condition. This is initial condition. You need an initial condition. So therefore, this one, I can take integration of 1/x². Should give you f of x. So I know how to do that because that's going to be x to the -2 dx. And that's going to be x -1/-1 plus c. Is that okay? Now, this is a reason why you need this, because that's going to be f of x equal to -1/x plus c. Now, with the initial condition, if you don't have the plus c, you don't know to find a c. There's a way to find c now, because this is the x and y value, right? I can plug it back in here, which is 0 equal to -1/1 plus c. So 0 equal to -1 plus c, c is equal to 1. So therefore, integration of this is going to give you a -1/x plus c plus 1 is equal to f of x. Now, sometimes you might have to do twice, because on your homework, there are questions that will give you f double prime of x. Let's say if you have this, I could have said this. I have to say like this equal to 4 equal to 8. I could have said f of 4 is equal to 10. And then you have to go to each one. You have to go to from the second derivative to take integration to get to the first derivative. But you're going to have plus c. Once you find a value of c, then you can do it again. And you can do it again. And you can find it, the original function. So sometimes you might have to do it twice. Today's homework, do me a favor. Don't look at the answer choice before you do all the questions. Cover it up, do it, and see if it matches. Okay, because that's the best way to practice SAT as well. Guys, do not practice SAT by looking at the choice. Practice it without a choice. You do it the logical reason without using common sense. And that's how you get better on your SAT score.
So with the do they need to tell you the first prime for you to figure it out?
Yeah, you have to do the first prime first. Yeah, the integral of the double prime become first prime.
No, but do they need to tell you that the prime of something is equal to this?